So if you do menu 3, 2, which is solve systems of linear equations, it'll tell you 270, 170, and 190. So from that, you'll have to discover that P was 270, M was 170, and G was 190. It goes in the order that you put in the variables. Moving on to number 19, if a parent function is transformed to -5 times f of x plus 7 minus 2, what would be the effect on the graph? So these type of transformations always occur in the same way. A times f of x minus h plus k. So that means A is -5, H is not 7, but -7 because that sign switches. And then K is -2. So if A is negative, that's a reflection over the x-axis. So I have a reflection over the x-axis. I also have H is -7. So that's going to move my graph to the left 7. And then -2 for K means I'm going to move down 2. So one thing you want to remember is that A can actually do two things at once. So it's negative, so it's a reflection over the x-axis, but also because A is 5 and not 1, then we're going to have a vertical stretch by a factor of 5. Number 20, identify the quadratic function graph to the right. One thing I noticed, the first thing I noticed is that it's concave down, or it's opening down. So that means that A has to be negative. A is negative. So with that being said, I can eliminate G and H as answers. The other thing I noticed is that my answer choices are in vertex form. And I can figure out my vertex right here. It's -2, 4. So that would be H and K. So I can see which one is plugged in for H and K, and that is F. The next one, find a write an equation for the parabola whose vertex is here, passes through this point here. One thing you can do if you have a calculator, you could definitely plug in those answer choices and see which one will match those points that you're given. If you don't have a calculator like me, then what you can do is plug these into vertex form equation as H and K and X and Y and figure out what A is. So Y equals A times X minus H squared plus K, where we know H is -5, K is 7, X is -3, Y is -1. So let's see if we can eliminate any just by knowing my vertex. So -5. So it should look like positive when I plug it in. So I can eliminate D, and then 7. Okay, so that's the only one I can eliminate. In any case, let's go ahead and continue to work this out. So I'm going to plug in those values for X, Y, H, and K. So let's see what we get. Y equals, and instead of Y equals, actually, I'm going to plug in -1 equals A times, instead of X, I'm going to put -3 minus -5. So plus 5 squared here, and then plus 7. Always do what's inside the parentheses first. So I'm going to have -1 equals A times 5 minus 3 is 2 squared plus 7. So that's 4A plus 7 equals -1. With that being said, I would just finish this up. So subtract 7 from both sides. So -8 equals 4A. Divide by 4 to get A equals -2. Since I know A equals -2, I pretty much can see my answer is C. but I'm going to go ahead and write it. I'm going to plug it in. So you always plug in A, H, and K. So my answer should definitely be answer choice C. For number 22, you have money in your wallet, but you don't exactly know how much. When your friend asks you, you say, hey, I have, give or take $50. So we're going to write an absolute value equation that kind of demonstrates this. So I'm going to have the absolute value of, we don't know how much it is. So whenever you don't know something, you put an X or Y, any type of variable really. Minus this number here, which is my $50, is less than or equal to 15. That way, if I were to solve this, I would have my positive and negative case, and it would work out to be, to tell me, hey, whatever $15 plus 50 is, and then 15 less than $50. So this is how I would set it up. So anything that it varies by, I write it on the outside. In what quadrants are the solutions to this system? So basically, I could go ahead and graph these, but you first want to know what quadrants are. So quadrant 1, quadrant 2, quadrant 3, and then finally quadrant 4 is over here. So it goes counterclockwise, 1, 2, 3, 4. If I were to graph this system, I could graph this in my calculator, and I would get something that looks similar to this. My solutions are actually where the graphs overlap or where they intersect. So they would be in quadrant 1 and 2. So the next one, simplify 4 plus 5i times 4 minus 5i. If you notice something about this, these are complex conjugates. So something interesting is going to happen here. So I'm going to just start out by distributing 4 times 4 is 16. 4 times negative 5i is negative 20i. 5i times 4 is positive 20i. And then 5i times negative 5i is negative 25i squared. Because these are conjugates, my middle terms here actually cancel. Negative 20i plus 20i, those actually cancel each other. So I have 16 minus 25i squared. One thing we know about I squared, however, is that I squared equals negative 1. So I have 16 minus 25 times negative 1, which is 16 plus 25, which turns out to be 41. For what value of k is x squared plus kx plus 49 a perfect square trinomial? So we're actually working backwards from what we usually try to find that c value, but we're going to work backwards from there. So usually we have b divided by 2 squared equals some number, but we know that number, it's 49. So let's work backwards and figure out what it is. So what I'm going to do is square root both sides. So I have here b over 2 is either positive or negative 7. And then I'm going to multiply both sides by 2. So b is going to be either positive or negative 14. We don't really know. It doesn't, it could be either one of those and still get the same answer. What is the range of f of x equals absolute value of 3x plus 4? Let's see. The easiest way to do this would be to graph that in your calculator, and it looks like this. The domain, it doesn't really ask for the domain, but just like a quadratic, the domain doesn't change. It's all real numbers. And the range is going to go from this y value onto infinity, so from 0 to infinity. Find the exact solutions by using the quadratic formula. So one thing you want to do when using the quadratic formula is notice what a, b, and c are, and sometimes that's difficult to do if you're not realizing that one side has to equal 0. So I'm going to arrange this a little bit differently. I'm going to subtract 5x and add 1. Subtract 5x and add 1. So I'm going to have 2x squared minus 5x plus 1 equals 0. Now I have a, b, and c. A is 2, b is -5, and then c is 1. I like to find the discriminant first. So I have -5 squared minus 4 times 2 times 1. And by working that out, I'll get 25 minus 8 is 17. So it's positive. I know I'm going to have two solutions, but they're going to be some yucky answers. They're going to be irrational. So I'm going to plug it in the quadratic formula now. X equals -b plus or minus squared b squared minus 4ac. All of that over 2a. So -b, let's see, is +5 plus or minus the square root of 17 over 2a. 2 times 2 is 4. Notice this number under the radical is prime. There's nothing I can do to simplify it. And notice that I don't have 3 terms to reduce. So this is going to be my final answer. We're going to solve this inequality here. So with inequalities, just make sure that one side has a 0 on it. So I'm going to go ahead and move the 2x and the 3. So I'll have 0 is greater than or equal to x squared minus 2x minus 3. I'm going to factor it. So -2 and -3. What adds up to -2 but multiplies to give me -3. So that's -3 and 1. X minus 3 equals 0. 1 equals 0. I'm going to solve these and then graph my number line. 3, x equals 1. So on my number line, I have -1 and 3. So I need to test a number that's smaller than -1. So let's go with -2. So if I graph -2 on my number line, I need to test that point. So I'm going to plug it into the original. 2 times -2 plus 3 is greater than or equal to -2 squared. -2 squared is 4. So I have -4 plus 3. That's -1 is greater than or equal to 4. That's not true. So let's test another point. Let's try 0. And let's see, 2 times 0 plus 3 is greater than or equal to 0 squared. So 3 is greater than or equal to 0. That's true. Third test point we're going to try is 4. So 2 times 4 plus 3 is greater than or equal to 4 squared. So 8 plus 3 is greater than or equal to 16? No. So my solution is going to occur between -1 and 3. So I would write my solution as an and type of problem. So linear, absolute value is shaped like a V. Quadratic is a parabola. For an equation that has a maximum, so I know that A is negative and a vertex here, so y equals -x minus 2 squared plus 7 for vertex form.